Hi, my name is Nancy Gu. I am from 3rd period AP Chemistry. This is my AP Chemistry final video project. The 30-minute long video I chose for this project is Introduction to Galvanic Cells and Voltaic Cells by the Organic Chemistry Tutor. The link is in the description below. In this video, I will be talking about electrochemistry. Specifically, I will talk about how voltaic cells work. A voltaic cell is a device that allows energy released from a spontaneous redox reaction to do electrical work. In a voltaic cell, two half reactions occur spontaneously. They are oxidation and reduction. An element goes through oxidation if its oxidation number increases, and an element goes through reduction if its oxidation number decreases. Now I'm going to talk about how to set up a voltaic cell. First, start off with two beakers. In one beaker, place a piece of zinc metal. In the other beaker, place a piece of copper metal. These two pieces of metals are called electrodes. 4 atoms of each of the two metals are shown. Now we are going to add different solutions into the beakers. The solutions must not react with the electrodes and must not form precipitates. In beaker 1, choose a solution that contains the ion version of zinc. That would be zinc 2+ ion. A good choice for the solution is zinc nitrate. I will show 2 sets of zinc nitrate compounds, each completely dissociated. The net charge of the solution in beaker 1 is 0. In beaker 2, choose a solution that contains the ion version of copper. That would be copper 2+ ion. A good choice for the solution is copper nitrate. I will show 2 sets of copper nitrate compounds, each completely dissociated. The net charge of the solution in beaker 2 is 0. We have finished setting up the 2 half cells. Now, attach wires that connect the electrodes. You can add a light bulb between the wires. A light bulb allows current to flow through it. When the cell is running and sufficient electricity runs through the wires, the light bulb will turn on. You can also add a voltmeter between the wires. However, in reality, the voltaic cell won't work well with a voltmeter because voltmeters have high internal resistance, but they are useful when you want to know the cell potential of a cell, which I will not talk about in this video. Lastly, a salt bridge is needed. A salt bridge is an inverted U-shaped tubing filled with a conducting solution with cotton plugs at the openings to keep the solution in. Ions are able to pass through the openings slowly. In this voltaic cell, we use potassium nitrate, but any conducting solution will work, although we try to avoid solutions that will form precipitate with other ions. In this video, the pink circle with a plus sign means the cation, K+, and the mint green circle with a minus sign means the anion, NO-. I will show cations and anions flowing inside the salt bridge. Our voltaic cell is now complete. Once the salt bridge is in, the cell will start operating and the light bulb will turn on. The next part is how voltaic cells operate. Let's focus on one zinc atom at the zinc electrode in the first half cell. The zinc atom is oxidized at this electrode, meaning it separates into 2 electrons and a zinc ion. The orange circles with the minus sign represent electrons. The zinc ion enters the solution surrounding the electrode, joining the other zinc and nitrate ions. The 2 electrodes leaving the zinc electrode, moving into the wire and toward the copper electrode. The electrode lost a zinc atom, while the solution gained a zinc ion. Now, let's focus on a copper ion in the solution inside the second half cell. The copper electrode is surrounded by a solution containing copper ions. These copper ions are positively charged, so they are attracted to the negatively charged electrons. The copper ion moves closer to the electrode and comes in contact with the incoming electrons. Copper ion is reduced at this electrode, meaning it combines with the 2 electrons and forms a neutral copper atom. The electrode gains a copper atom, while the solution lost a copper ion. The net charge of the zinc nitrate solution and the net charge of the copper nitrate solution are not balanced. In reality, when solutions in the 2 half cells do not have the same charge, the cell does not work, and the light bulb won't turn on. That is where the salt bridge comes into use. In there are potassium ions and nitrate ions. we see that the solution in the left half cell has a +2 charge caused by the addition of a zinc cation, and that the solution in the right half cell has a -2 charge caused by the loss of a copper cation. To make the solutions have the same charge again, 2 nitrate anions will enter the solution on the left, and 2 potassium cations will enter the solution on the right. Now the net charge of both solutions is 0, and the voltaic cell is working. The salt bridge does not only work one way. Ions in the solution of the beakers can also move into the salt bridge, and eventually the ions of 3 solutions will mix together in a way where net charge of the cells are balanced. Now I'll talk about some terms specifically applying to voltaic cells. We know that zinc atoms get oxidized at this electrode, meaning oxidation occurs at the zinc electrode. By definition, the electrode where oxidation occurs is called the anode. So this zinc electrode is the anode. We know that copper ions get reduced at this electrode, meaning a reduction occurs at the copper electrode. By definition, the electrode where oxidation occurs is called the cathode. So this copper electrode is the cathode. One way to remember this is oxidation and anode both have a vowel in their first letter. And reduction and anode both have a consonant as their first letter. The direction of the motion of electrons is from the anode to the cathode. The anode has a negative charge and the cathode has a positive charge, because naturally electrons move from a negative area to a positive area. To remember this, N comes before P just as A comes before C. Now I'll talk about the direction of the motion of ions in a salt bridge. Ions are moving in the solution with the anode. Remember this by saying A into A. Cations are moving into the solution with the cathode. Remember this by saying C into C. Now let's write the final balanced redox reaction. First, write the half reactions. The oxidation half reaction is solid zinc goes to aqueous zinc ion and 2 electrons. The reduction half reaction is aqueous copper ion and 2 electrons goes to solid copper. These 2 half reactions are already balanced in terms of charge and the number of atoms of each element. These 2 half reactions also have the same number of electrons. So now add the 2 half reactions. Cancel out the 2 electrons on each side. You end up with the final balanced redox reaction. Solid zinc and aqueous copper ion goes to aqueous zinc ion and solid copper. And finally, I will summarize the key points to remember. Oxidation occurs at the anode. Reduction occurs at the cathode. Electrons move spontaneously from anode to cathode. The anode has a negative charge. The cathode has a positive charge. Anions move toward the anode. Cations move toward the cathode. The balanced redox equation for this example is solid zinc and aqueous copper ion reacts to form aqueous zinc ion and solid copper.